there, human calculators. This is Teacher Josie giving you food for the brain. Today's episode is solving system of linear equations into variables by graphing. Let's have first the 15 seconds to win it activity. So you are going to answer the question in 15 seconds. Question number 1. Which of the following graphs shows system of linear equations with infinite number of solutions? Is it A, B, C, or D? What's your answer in number 1? The answer is C. As we can see in the figure, the two lines are coinciding. The kind of system of linear equations is consistent dependent. We recall that in this type of system, the slopes are equal and y-intercepts are also the same. Question number 2. Which of the following figures shows system of linear equations whose graphs are intersecting lines? Is it A, B, C, or D? The answer is A. Remember, when the two lines are intersecting, the kind of system of linear equations is consistent independent. The number of solutions is exactly 1. When we compare the slopes of the two equations, they are not the same. If we also compare the y-intercepts of the two equations, they are also different. Question number 3. Which of the following graphs shows system of linear equations with same slope and different y-intercepts? Is it A, B, C, or D? The answer is letter B. Since the two lines are parallel, there is no point of intersection of the two lines no matter how far we extend them. Again, for inconsistent system of linear equations, there is no solution. We recall that in this type of system, the slopes are equal and y-intercepts are different. Let's have question number 4. A blank is a set of two or more equations of the same variable in each equation. The answer? System of linear equations. Number 5. A blank of system of linear equation is an ordered pair that makes both equations true. The answer is solution. Did you get all the correct answers? Very good. How do we find the solution of system of linear equations into variables by graphing? Solving system of linear equations by graphing is done by determining the point of intersection of the two graphs, which represent the values of x and y that satisfy the equations. Here are the steps in solving systems of equations by graphing. 1. Graph each equation on a single set of coordinate axes. In graphing each equation, you may use any of the three methods: two-point, intercept, or slope-intercept. 2. Find the coordinates of the point or points where the graphs intersect. Do the lines intersect? If yes, what are the coordinates of the point of intersection? If the graphs have no common point, the system has no solution. If the graphs of the equations coincide, the system has infinitely many solutions. And 3. Check the solution or solutions in both of the original equations. Since graphing is not perfectly accurate, check the coordinates of the point of intersection of both equations. Number 1. Solve the system x plus 2y equals 4 and 2x minus y equals 3 by graphing. Solution: graph both equations in the same coordinate system by plotting their intercepts. So we will give the x-intercept of equation 1, identify also its y-intercept. We will give the x-intercept of equation 2, identify also its y-intercept. Let's have equation 1. X plus 2y is equal to 4. For the x-intercept, we will let our y be equal to 0. So x plus 2, our y is 0, is equal to 4. Copy x plus 2 times 0 is 0. Copy equals 4. So on this side, we have x is equal to 4. We have the point 4, 0. For the y-intercept, we will let our x be equal to 0. So 0 plus 2y is equal to 4. We have 2y is equal to 4. Dividing both sides of the equation by 2, our y is 2. So we have the point 0, 2. Let's have equation 2. 2x minus y is equal to 3. So we will find the x-intercept. We let our y be equal to 0. So copy 2x minus our y is 0 is equal to 3. So we have 2x is equal to 3. Dividing both sides of the equation by 2, we have x is equal to 3 over 2. We now have the point 3 over 2, 0. For the y-intercept, we let our x be equal to 0. So 2, our x is 0, minus y is equal to 3. What's the product of 2 and 0? It is 0. Copy, negative y is equal to 3. So we now have on this side, negative y is equal to 3. Dividing both sides of the equation by negative 1, we have y is equal to negative 3. We now have the point 0, negative 3. So let's have the graph of x plus 2y is equal to 4. We plot the x-intercept. Next, the y-intercept. Connect the 2 points. So that's the graph of x plus 2y is equal to 4. Let's have equation 2. The x-intercept is 3 over 2. We plot it. So we have here the x-intercept. Next, the y-intercept. So here is our y-intercept. Connect the 2 points. So this is now the graph of 2x minus y is equal to 3. So what can you say about the 2 lines? They are intersecting. So what is the point of intersection of the 2 lines? It is 2, 1. Let's check in equation 1. X plus 2y is equal to 4. Our x is 2. Our y is 1. Is equal to 4. So copy 2 plus 2 times 1 is 2 is equal to 4. 2 plus 2 is 4. Copy equals 4. Do we have a true statement? Yes. What about in equation 2? 2x minus y is equal to 3. Copy 2. Our x is 2. Our y is 1. Copy equals 3. 2 times 2 is 4. Copy minus 1 is equal to 3. 4 minus 1 is 3 is equal to 3. Do we have a true statement also in equation 2? Yes. Since we obtained true statements in equation 1 and equation 2, the solution of the system is 2, 1. Let's have example 2. Solve the system 2x minus y equals 3 and 2x minus y is equal to negative 1 by graphing. Solution: graph both equations in the same coordinate system using 2-point method. So this time we will make use of 2-point method. So assign any value of x and solve for y. Let's say in equation 1, when x is 1, what is y? When x is 2, what is y? Also in equation 2, when x is 1, what is y? When x is 2, what is y? Let's have equation 1. When x is equal to 1. So copy 2. Our x is 1 minus y is equal to 3. 2 times 1 is 2. Copy minus y is equal to 3. So negative y is equal to what? So we add negative 2 to both sides of the equation. We apply the addition property of equality. So 3 plus negative 2 is 1. Then we divide both sides of the equation by negative 1. So we now have y is equal to 1 divided by negative 1 is, yes, it's negative 1. So we have the point 1, negative 1. So when x is 2, what is the value of y? So copy 2. Again, x is 2 minus y is equal to 3. 2 times 2 is 4 minus y is equal to 3. So again, we will apply the addition property of equality. What are we going to add to both sides of the equation? Correct, it's negative 4. So we have negative y is equal to 3 plus negative 4 is negative 1. Dividing both sides of the equation by negative 1, we have y is equal to 1. So we now have the point 2, 1. Let's have equation 2. 2x minus y is equal to negative 1. When x is equal to 1, what is the value of y? So copy 2, our x is 1, minus y is equal to negative 1. 2 times 1 is 2, copy, minus y is equal to negative 1. On this side, we have negative y. And we will add negative 2 to both sides of the equation. So negative 1 plus negative 2 is negative 3. We applied the addition property of equality. Dividing both sides of the equation by negative 1, so our y is equal to negative 3 divided by negative 1 is 3. So we have the point 1, 3. When x is equal to 2, what is the value of y? So 2, again our x is 2, minus y is equal to negative 1. 2 times 2 is, so we have 4. Copy, minus y is equal to negative 1. Then, we will add negative 4 to both sides of the equation. So that on this side, we only have negative y. So this is equal to negative 1 plus negative 4 is equal to negative 5. Divide both sides of the equation by negative 1. We have y is equal to 5. We now have the point 2, 5. Let's have now the graph of 2x minus y is equal to 3. So let's plot 1, negative 1. Next, 2, 1. Connect the 2 points. So that is the graph of 2x minus y is equal to 3. Let's have the graph of equation 2. We plot 1, 3. Then 2, 5. Connect the 2 points. So that is the graph of 2x minus y is equal to negative 1. What can you say about the 2 lines? Do they have point of intersection? So the 2 lines are parallel. There is no point of intersection. So we say that the system has no solution. 3. Solve the system by graphing x plus 3y equals 3 and 2x plus 6y equals 6. Solution: graph both equations in the same coordinate system using slope-intercept method. X plus 3y equals 3 is in standard form. Rewrite it in slope-intercept form since we will use slope-intercept method in graphing. So separate the y term from the x term and constant term. So on this side we have 3y because we added negative x to both sides of the equation. So we have equals negative x plus 3. Dividing both sides of the equation by 3, we have y is equal to negative 1/3 x plus 1. So what is the slope? It is negative 1/3. What about the y-intercept? It is 1. Let's have the graph of x plus 3y is equal to 3. Y-intercept is equal to 1. So here is our point, 0, 1. The slope is negative 1/3. Since the slope is negative, we expect that the line falls from left to right. Also, slope is equal to rise over run. So 1 here is our rise and 3 here is our run. So from this point, move 3 units to the left and 1 unit up. So here is our point. Or we can have also 3 units to the right and 1 unit down. Connecting the 2 points, we have here the graph of x plus 3y is equal to 3. 2x plus 6y is equal to 6 is also in standard form. Rewrite in y equals mx plus b. So separate the y term. We have here 6y is equal to negative 2x plus 6. We added negative 2x to both sides of the equation. That is why we have here negative 2x. Dividing both sides of the equation by 6, we have y is equal to negative 1/3 x plus 1. Take note, we reduce this to lowest term. And 6 divided by 6 is 1. So what is the slope? It is negative 1/3. What about the y-intercept? It is 1. What do you notice of the slopes and y-intercepts of equation 1 and equation 2? Yes, we have the same slope and the same y-intercept. So where will be the graph of equation 2? Let's see. So y-intercept. So we have here also the point. And so with the second point. Connect the 2 points. So what kind of graph do we have in this system? Yes, they are coinciding. The kind of system that we have here is consistent dependent. So the number of solutions is what? It is infinitely many solutions. So we now write the system has infinitely many solutions. This time, I want you to try this. The solution of the system 3x plus y equals 5 and 2x minus y equals 5 is 2, negative 1. How are the graphs of the two equations related? A. The graphs are parallel. B. The graphs coincide. C. The graphs intersect at 2, negative 1. And D. The graphs intersect at 2, 0 and 0, negative 1. You will answer it in 15 seconds. What's your answer? Since 2, negative 1 is the solution of the system, that is their point of intersection. So, the correct answer is letter C. The graphs intersect at 2, negative 1. Number 2. At what point do the graphs of the equation 2x plus y equals 6 and x minus y equals 3 intersect? A. 0, 3. B. 3, 0. C. Negative 3, 0. And D. 6, 3. You are going to answer it in 30 seconds this time. What is your answer in number 2? Let's check. So we will use the x and y intercepts in graphing. In equation 1, when y is 0, what is x? It is 3. So plot 3, 0. Next, when x is 0, what is y? It is 6. So plot 0, 6. Connect the 2 points. In equation 2, when y is 0, what is x? It is 3. So, plot 3, 0. When x is 0, what is y? We have negative 3. So, plot 0, negative 3. Connect the 2 points. So what can you say about the graph? They are intersecting. We have the point of intersection 3, 0. So that is the point of intersection of the 2 lines. What is the answer in number 2? It is letter B. So, how do we solve systems of linear equations in 2 variables by graphing? 1. Graph each equation on a single set of coordinate axes. 2. Find the coordinates of the point or points where the graphs intersect. And 3. Check the solution or solutions in both of the original equations. Reminder, be careful in graphing. This method of solving system of linear equations has one weakness, that of accurately determining the coordinates of the point of intersection of the lines. A slight difference in the scaling of the coordinate axis can lead to a completely new set of coordinate readings. That's all for now, folks. See you around in our mathematics world. Have fun in graphing!